Testing? Works. Great. I believe it's 1:45. Please take your seats as soon as you can. Awesome. My name is Chris Noring. I am here from London. I'm here to talk about RxJS, a neat little library that quite a few people are using, mostly, I think, because of Angular. So I'm here to talk about... strange. We have to wait for the feed for a few seconds, I think. Unless it was my computer, of course. Could have been. Yeah, it was. If it falls asleep, then... All right, let's do it again. So this is me, Chris Noring, Google Developer Expert, Progress or Telerik Developer Expert. I work for Digital McKinsey. This is my Twitter tag if you got any questions or want to see what I tweet about. Let's begin. So, asynchronous code. We all love asynchronous code, especially if we don't use promises or RxJS, right? Callbacks. Callbacks are a problem when it comes to asynchronous code because they promote code that looks like this. We start off good. We have a getData function. Then we realize we need another function because we have a dependency. The first function needs to complete before the other function can be invoked. As you can see here, we use the data from the first function as an in parameter to the next call, and so on. Quite quickly, this becomes unmaintainable asynchronous code because your eyes are bleeding when they look at this. You agree? Yeah. We feel like this guy. We're crying, and we're throwing a fit. And we know that this is called callback hell. It is painful. There are solutions. There are, for example, promises. Because the name of the game here when it comes to asynchronous code is to make sure that it's readable in a synchronous way, right? So promises enables us to just chain all of our method calls in the order that we want. So here we can clearly see what happens first, what happens second, and what happens last. This is what promises does for us. But of course, we got this guy, this new kid on the block, asynchronous await. And by using that one, we can suddenly have a very flat-looking code. Suddenly, we can just call it like this, right? First call, get data. Second call, get more data. And the third call, get even more data. And it actually looks like any other code out there. How many are using async await? How many are still suffering with callbacks? Sorry, guys. What about promises? At least you're on promises, right? Oh, yeah, that's good. That's good. You've seen the promised land. So, question is, when I know promises, when I know async await, why should I just, adopt another library? I mean, I was pretty happy with promises, right? I was able to chain my code. Everything was happy. I was able to turn my promises into async await. Suddenly, everything was good. So why am I standing here talking about RxJS and tell you pretty much to abandon promises? There is a reason for that. You have scenarios when you code asynchronous code that are painful to do. It takes a lot of code. The code doesn't turn out pretty. One of those scenarios are connectivity. You've got internet that goes up and that goes down. It's completely out and it's suddenly on again. You have to have code that caters to this. You have scenarios where your applications suddenly aren't request response. They're not as simple anymore of just doing get products. You might actually have APIs that the data might actually arrive at any time, and you really don't know when the data will arrive, right? So it's more like a kung fu game. The data comes from here, you try to push it over here. Well, the data comes here. You don't know if they're going to arrive in half a second or 2 minutes, but you need to cater to it. The main point I'm trying to make is that asynchronous code becomes messy, especially when you have a lot of endpoints and you can't really trust the endpoints as to when the data will arrive. And of course, there are limitations to promises. They only return one value. They're hard to retry. They don't have cancellation, and they don't mix with other asynchronous concepts. Because AJAX calls are not the only asynchronous concept out there. You also have UI events, for example. So wouldn't it be really nice if you got one paradigm only? So that's why we have RxJS for all those mentioned reasons. The limitations of promises and the fact that suddenly we have this big promise out there, not that kind of promise, but we have this big promise that suddenly we can mix all of our asynchronous concepts into one concept. One of the most important players in RxJS is the observable. So the observable, when you first look at it, it looks like a combination of arrays and promises put together, and I will just show you why. So here you have a simple array at the top. The array here has methods on it called map, filter, and take. A promise has a then callback when it's done. So if we mash those two together, this is what we get. So you see here we have the influence of an array and the influence of a promise, but instead of calling it then, we call it subscribe, and suddenly we are writing RxJS. It's very easy to say that this is all there is, but of course there is more. But we should remember this. If we mix up the behavior of arrays with promises, with the fact that we can now handle canceling and retry, we actually get superpowers. But of course, except for observable, there is this concept called observer as well. And an observer has 3 methods on it. It's just an object. So the observer in this case has the methods next, error, and complete on it. And using it, you do it like so. So in this case, we are creating an observable using the create method. As you can see here, we have a function that it takes, and that function as a parameter has the observer. The observer calls the next method with a value, which means it's emitting a value. It's calling complete, which means it's saying that there are no more values to be had. So it's effectively closing the stream at this point. Let's look at another example. We have the same thing as we had in the previous slide, but here we can say that we involve another guy, the error. Let's see how all of these actions match to callbacks below. So here we have observer next, which means that our first data callback here at the bottom will be hit. When we call observer error, the second callback will be hit. And when we call complete, the last one is being hit. So long as we understand what happens when. When we emit data, when we emit errors, or we try to close the stream. I'm going to pause here for a little second, because this is really the basics of observables themselves. So if we understand this construct, we understand how to work with them at the basic level. But of course, all these observables, or streams, as we also like to call them, they wouldn't be anything unless we're able to actually get the data. So what we need to do is to call subscribe. We did that in the previous slide. We did the subscribe. But now we are assigning the subscribe into a variable, a subscription. That variable, we are able to call unsubscribe on it, which effectively means we stop listening. As you can see here, we are waiting 3 seconds before we actually do it, because if we do it right away, then the values won't actually be emitted, because it will just close. So why are we calling unsubscribe? We're calling unsubscribe because there might be behaviors inside of an observable that we need to fix. In this case, we have started with this interval function. We are emitting values seemingly once per second for all eternity. So the problem of us just doing an unsubscribe without defining this yellow function here would be that it would keep going despite the fact that we have stopped listening. So what we need to do inside here is to define this cleanup function that's called IamCalled on unsubscribe. What you can see here is that we call clear interval with the ID variable that we get here at the top. So this is just a simple example, but it gives you an idea of why we do it. So if we create our own observable, we need to make sure that we have a cleanup behavior, especially if we do this kind of behavior. So remember, if you create your own, make sure you have a cleanup function, because this yellow function here will be called when you call unsubscribe. So that's really how the basics of it works. Of course, in most cases, you won't be creating your own observables like this. There are definitely scenarios when you do this. For example, you're wrapping something else, a promise or a callback, and try to make it into an observable. But most of the time, you will create it from something. And this something is a factory function. And there are tons of factory functions within the RxJS library. So here, for example, we can create an observable from a list of values. We can create it from a promise. We can create it from just a few numbers. We can create it from UI events. Now it becomes interesting. Now we can suddenly mix and match different types. Values, asynchronous, UI events, time intervals. The fact that these can be thought of as one and the same thing, the observable, makes it super powerful. So suddenly, imagine that everything you do can be reactive. Everything asynchronous can be thought of as one pipe, one concept. I'll show you another example here when we are actually using the create operator that I just told you about. So the thing we need to remember is before we try to enact any kind of wrapping, we need to make sure that we fulfill this protocol, right? For a wrapping to be considered complete, we need to follow some rules. We need to make sure that when data are emitted, we call observer next. When an error happens, we call observer error, and when we're done, we call observer complete. We have that in our heads. And now let's get to the actual wrapping. Vanilla Ajax. We haven't written one of those in 5 to 10 years, right? Here we have a request. As you can see here on the onload, we get our data. We are calling observer next on the data we get. We are calling observer complete because in this case, we know we only have one value back. But as you can see, we also hook up on the on error, and here we call observer error. So we emit the data with next, we close the stream with a complete, and we make sure we call observer error. Thus, we have wrapped this completely. So imagine that you can use this kind of construct on everything that's not an observable. It could be static values, it could be callbacks, it could be anything. So this is how you do it. Any questions so far? All right, you're all sleeping. Great. Operators. So far, I just talked about the create method, but in truth, observables and RxJS wouldn't be what it is without a lot of function that's already made for you. Without those, it wouldn't have any value. So really, they give it its power. 60 plus operators. Steep. You're just starting to learn, right? Come on. 60 operators, they're going to take me as long as learning Angular or Vue. But in truth, RxJS 4 had 120 operators. Were there any of you who tried out the version 4 of RxJS? Okay, good for you. I actually did a talk on that. That was a few operators to cover. So what I'm trying to say here is that you probably need to learn 5 or 6 operators to begin with. You don't need to learn this daunting 60 plus operators. That's good to know, right? And also consider the fact that you can actually divide them into categories like construction, conversion, combination, mathematical, and time-based. Thus, you just need to pick off a few operators from each category. You don't really have to know everything. I said this. So imagine that your operators are applied in the following manner. Imagine that you define your observable like this. Then you have X number of operators that happens after each other. They're chained up like this. And lastly, you got the subscribe. So this is really how you should construct things. So imagine that you apply the first operator, something changes based on that. You apply another operator, and so on. Marble diagrams. This is how we learn visually what an operator does. So these guys are visual. They represent our values on a line that is as long as it needs to be, because we're talking asynchronous. This line could be half a second long. It could be hours long. Point is, the line is time. These are values over time. So here you can see at the top here is a stream with values. we see here there's a second stream, also with values, and suddenly we see the merge operator. And the third stream is the resulting stream. This is the result of applying a merge on those two. What you need to remember when it comes to these marble diagrams is that they can do two things. They can either do something with your values and X number of streams, but they can also change the time aspect. In this case, it's just a merge, right? But there could be some other operator that actually makes sure that the values happen more seldom or more often. So remember, they represent what happens when you apply an operator. Most operators here are covered at rxmarbles.com, so this is a very good entry point for your knowledge, for you to learn more about RxJS. So, some operators at work. We start off by defining an observable with the values 1, 2, 3. That's all it's ever going to emit. We have the projection operator, or the map. In this case, we take every single value and just add 1 to it. Very simple. The second operator here is a filter. So this guy effectively stops values from being emitted. You give it a Boolean argument that says anything that's divisible by 2. So this means we're only going to keep the 2, pretty much, right? We're going to throw away the 1 and the 3. They will never be emitted. But as you can see here, we apply these operators chained, one after another. This is very important, of course, to know what we're doing. We need some kind of debug functionality. How many of you are on RxJS 5.5? Okay, no hipsters. So in 5.5, we changed name of the do operator to tap. So, but if you're still on RxJS 5, it's still called do, and it's still backwards compatible. So if you type do, it's still going to work. Point is, the do operator just inspects your value. It doesn't actually change them, which is a very good debug candidate. So here we have created our observables. We apply our do, and of course, at this point, we haven't really changed anything, right? So we expect the 1, the 2, and the 3 to be emitted. But here, the next do is actually after the map and after the filter. So here we expect a change. So here we can actually expect if this does what we think it does. So when you need to inspect your stream here or your observable, just apply a do before and an after, and you're able to see what actually happened. All right. So far, we had very nice streams, right? We just had one stream, a subscribe, everything is nice and simple, and yeah, okay, I kind of get this. Suddenly, you realize that you want to write code that looks like this. This has a consequence, because what we do is that we hook up to a key up event from the UI. And we're saying essentially here that on every key up, we are going to want to do an AJAX request. So the problem there is that we use a map operator. So first off, we dig out the actual key. Thereafter, we try to do an AJAX call based on that. Here's the problem, though. Imagine that you tapped a key 5 times. We will have a list of 5 observables, right? We want the value. We want the value. We don't want a list of observables, because a list of observables is actually what we're going to get here. So we have a problem. We need to flatten out this list, because what we essentially need to do is to loop through every observable in that list and say, subscribe to you. We can fix this. We can fix this with an operator called flatMap. So this one does the heavy lifting for us. It takes this list of observables, and it flattens it out to make sure that we just have one meta stream. When we have that one meta stream, we can actually get a stream of JSON instead, which is what we want. Very good one. But of course, there are cases when flatMap isn't your ideal match. It's not your ideal match, for example, when you do AJAX requests and you're in the UI, you have a drop-down of users. Let's say you have a drop-down of users. You have 2 different users. Based on that drop-down, you have another list of orders based on a user. So imagine you have this super fast user. He first off selects Adam, and then he gets a list of orders, but he's super fast. So while that AJAX request to orders is happening, he decides, no, I want to list orders by user Eve. At that point, you have a lot of AJAX hanging in the air. You want to cancel that. So you can't really do that with flatMap. So for that reason, you got this instead. You got the switch map. So the switch map is actually able to say, I want to cancel whatever happened because the precondition have changed. So in most cases, Ajax, I would say go with switch map because you might have this case. So imagine now that we have the get user. We don't really care about the fact now that the user is able to go into our UI and just flip the drop down. We don't care because we're able to use switch map and we just say, oh, well, I know you're going to take 3 seconds, throw you away. So they're very similar, the flat map and the switch map, but there is a difference and it's important. Of course, how do we actually build things? How do we go from requirement phase to actually understand how to build something valuable in RxJS? Let's take a very known example, if you've seen any lectures on RxJS, the autocomplete. It's a very good example. It's a bit tedious if you've seen it before, but the point is still, we are able to map. So let's start off with requirements. So requirements from an autocomplete is to listen to keyboard presses. Okay. We need to do a server trip at some point after X number of characters are entered. We need to do an Ajax call based on a filtered input. We need to cache responses, right? Because we don't want to go and do a server round trip based on the same input again that we just did like 2 seconds ago. And of course, we got the procedural approach, which is not so ugly, and this is the reason why I'm talking RxJS today. It's readable still, right? We're able to hook up to some kind of key up event. We're able to check whether we have at least 3 keys. We have some code here where we say, if it's cached, try to retrieve the response list from the cache, and if so, build that list in the UI. And if we don't have it cached, then we do an Ajax. This is still readable. This is on 1 page. We can consume this. We can understand this. This is not pretty, though. There are prettier ways to do this. And we will start with a streaming approach. So this is a change of our mindset. Imagine this instead. So instead of the procedural approach, we must consider the fact that every time we type, we have a key that's being emitted. But it might happen after 1 second, half a second, or 2 minutes. Point is, we can still model that the same way. So imagine that we have a bunch of keys. We want to group them in a bunch of 3 here. And at that point, we do some kind of Ajax call. That gives us a response back. And we will probably want to do some kind of mapping operations to dig out the JSON. And that JSON is what we serve the UI so it can show us our autocomplete. This is a big shift. This is not how we used to code things, but this is asynchronous, and this is a very valuable approach. So imagine instead that that procedural code turns into this. We hook up to a key up. We do a map to dig out the value. We check whether we have enough characters. If so, we call this operator distinct until changed. What's this? So distinct until changed means that we have a caching functionality. It's actually able to tell us that, imagine that we first type ABC. We do a server round trip based on that. Then suddenly we change our minds and we tap AB. That's also in Ajax request. But then suddenly we add the C. All this within the interval of 10 seconds or 2 minutes or wherever you want to put the limit. Point is still, we don't want to do another Ajax call based on that same ABC because we expect the same answer. So distinct until changed will ensure that if we type this before, it's in the cache. Retrieve from cache. And of course, we have the switch map, which I told you was better than the flat map. So the switch map is able to do a JSON call, Ajax call based on that. And essentially, at the bottom here, we're just able to subscribe to whatever JSON comes back. This is just a chained approach. We're able to take it stream by stream, operator by operator, and we are able to get something back that we can build and show in the UI. So why are we talking RxJS versus promises at this point? We have all been this developer that goes into a developer team and says, hey guys, I saw this really neat framework that I tested during the weekend. Can we just put it in here, or a library? Right? Everyone's like, I don't know. How many dependencies do we have now? And how hard is it going to be for the next guy who enters the team? Here's the thing. If you're going to sell a library and put it into your project, you need to make sure that you can actually do what the old library that you want to discontinue does, right? So if you're saying, I want to throw away promises for RxJS, everything you know about promises, you need to make sure that you can transfer that knowledge into RxJS and streams. If you can, it's a better sell. We've all been this developer, right? We walk into this developer room with your mates and you say, we want to use library X and library Y. There's no business value to it, but it's cool, right? So how do I do whatever knowledge I have? How am I able to replicate that in RxJS? Well, you have this very simple scenario. We have promises here. We have a then callback, we have a data callback, and an error callback. We have an RxJS version of this. We simply replace then for subscribe, but with the added third callback. We have cascading calls. Cascading calls are calls that are dependent upon each other, right? We need to wait for a login to happen before we are able to grab some data, or we're able to wait for something else. So in promise land, we would write something like this. We would write get data and a promise resolve. With the observable version, we'd be writing this. Very similar. But if we think about it this way, we have the chained approach in promises. We have a then for every cascading call that we do. Simply just replace it with switch map, and we're home. And of course, a little reminder of the switch map and the fact that we should be using that over flat map. I know I'm really hammering down on you here, but the switch map is really the one that you want to use when we have dependent calls and we have a case where we want to cancel previous calls. But we talked about cascading calls, but there are actually semi-dependent calls as well. So semi-dependent calls, in this kind of call, we're able to do a get user, and we get our user back. We realize that, well, messages and orders, I can fetch that separately, right? I don't actually need to wait for messages to arrive before I can fire away get orders. So what I do essentially here is that I get my user, and separately I send them out both to, say, retrieve my data. And once all of that is done, I'm able to actually update the UI. So if the observable approach to this, instead of promise all, we just do a fork join. So with the fork join, we're able to say, everything I knew about promises, I now know how to do in RxJS. I'm going to let that one sink in a bit. Error handling, our next topic. Error handling is important to get right, especially with streams, because it can easily be very complex. Imagine that you suddenly have this powerful library RxJS, and it allows you to do a lot of very cool things. But if you don't know how to handle errors, you might have a problem. Streams will fail on you, so there are different approaches that you can take to fix that. Here is one version, the catch and transform. The other way of doing it is the ignore, and the third approach is to retry it till it works, or the optimist, as I like to call it. Here we have no way of handling errors, right? Imagine that this happens internally in a stream. Something went horribly wrong. You have a stream that emits a value, and suddenly there's an error that it occurs. And in the subscribe, you're able to get the first value, you're able to get the error, but no completion. This is a dangerous situation, and you're thinking, do I actually need to handle this? I just put a catch somewhere, right? Should be possible. So yes, you can put a catch somewhere. You can add a catch operator. Here's the thing, though. The catch operator has a contract that it needs to fulfill, and the contract it needs to fulfill is to actually return an observable. So in this case, we are returning the error message. We could be returning anything at this point, but the point is still, we are able to capture the error, and we are able to create a new observable from it. So this one essentially hides the error. We're just saying, we got this error, we know. So imagine that our data callback here is being hit twice, one with the 1 and then with the some error. This might not be actually what you want. It's worth thinking about. I mean, yeah, sure, it's easy to do a catch, but we also have the ignore an error. So with the ignore an error, we have, imagine that we have different streams coming from different endpoints, and suddenly you realize, how should I handle the fact that this stream might fail, or this one might fail, one of you might fail, but I'm actually interested in the ones that live, right? The ones who actually deliver data. What happens if we do nothing? We are the optimist here. We go in here and say, well, I got the first stream here with 1, 2, 3. I got the second error stream, and then I got my third stream. I'm trying to merge all these 3 streams together. So what's the end result? The first stream is actually able to deliver all its values, 1, 2, 3. The second stream ruins the party. The second stream will actually make sure that the third one fails completely. It never gets a chance. So we need to handle this scenario if we want to make sure that all the good streams survive. And by using an operator called onErrorResumeNext, we're actually able to do that. So this one is pretty much to say, I don't care if you fail, just get out of my way. That's what this operator is saying. So here we are merging together 3 different streams, 2 of which are erroneous. We can see that beforehand. So in this case, the third stream don't have to worry because of the onErrorResumeNext. Yes, the 2 other ones just errors out, but nobody cares. The 4 and the 5 still get submitted. Now we have the retry, the optimist, the true optimist. Let's look at the simple version of retry first. So we use the retry usually when we have an internet connection that is very intermittent. Sometimes it works and sometimes it doesn't. Looking at the simple version, we can see here that we are able to delay when the error callback is being hit. So in this case, we're going to try this stream here 5 times before we actually give up. Here's the problem, though, with the network. Most likely, it's going to take it 20 seconds or 30 seconds or 5 seconds, or how many seconds you can imagine. So just retrying it straight away is not a good approach, but it is a approach. So depending on what the stream is like, if it's a failing network connection, or if the fact is that, sometimes the stream just fails, then retry can be used. But retry really needs to be used in combination with something. And the combination with something is time. So imagine that you have this network thing that fails. We're able to say delay. We're able to say delay with X number of milliseconds. But of course, you'd rather have a combination of these 2. I have that in my free RxJS book, by the way, so I'll be able to show you. Pretty much the point is also in a network, you're most likely that you want X number of milliseconds here to increase. So imagine that your first try was after 200 milliseconds. Then maybe you want to try again after a few seconds, and the time after that, probably even more seconds, right? You're not giving up, you're trying to be an optimist. Testing. We all love testing. How many are using RxJS currently? Few hands. How many of you are on Angular? But not using RxJS. Interesting. Are you using fetch or promises? Okay, that's probably why you're here. You're not actively using it. You're scared of it, am I right? Yeah, I was scared of it too. I mean, first time I saw it, it's like, why? We had promises. We had understood promises. Why this new library? For who? Is it for the Google people or for us? But yeah, how many are testing their code at all? Okay. Brave souls to not put up your hands. All right. How many are testing asynchronous code? Quite a few. That's good. There are testing capabilities within RxJS, but it's painful. We know this, right? So our first question we need to ask ourselves when it comes to asynchronous testing is, can I test something that may take 2 seconds or 2 minutes to complete? The answer is yes. And the answer in RxJS is called marble testing. Anyone used marble testing? Yeah, that made Ben very sad. All right. So the reason marble testing works is because we have something called a virtual clock. You as a programmer want to dictate when time happens, right? You don't want to wait those 2 minutes for it to complete. You want to say, 2 minutes is now. And that's what you do with a virtual clock. So imagine that you start out with this. It's gibberish, right? You can't really read this. XYZ, hash, And then we have XYZ pipe. It's Greek, right? Here's the thing. Those actually mean something. So the dash or the hyphen here means that the time has passed. The pipe means that we have an end of stream. And the hash means that an error has occurred. And the XYZ is just placeholder characters for our values. So let's go back a step here and look at this. Sorry, wrong direction. Let's go back to this guy then. So suddenly XYZ means our values, and the dash between them means time passes between values, and the hashtag means error, and the pipe means a completed stream. So suddenly we can see here that we are trying to do a match here between an expected and an actual. And yes, this one will fail, because not every single symbol is the same. It's kind of good to know that when we try to attempt marble testing, we need to decipher this one first, so we're able to express our tests. Let's look at some code. We are developers, after all, right? So we start off with a marble. We say XYZ, so we have 3 values that's going to be emitted. We have some time in between. And we also have some kind of map where we translate the X to mean a 1, a Y to mean a 2, and a Z to mean a 3. Moving on, we can see that we are creating something called a hot observable. And this guy is able to, well, let itself be controlled time-wise, the one with the virtual clock. This guy here, my algorithm, this is the code that we're trying to test. So this one has an observable that we create. It has X number of operators. And of course, we take the my algorithm here, and, well, I'm kind of short here, but we take our expected guy here. So we take our algorithm, we take the hot observable that has the expected pattern, and we put them in there, and we hope for the best. Once we've done that, we're able to assert. We're able to say that, okay, expected versus actual outcome, do they match? And the last thing we need to do in our test is to just fire it off, and we do that with a flush. This is the same code for each and every single RxJS code that you're trying to test. That's good to know. It doesn't get harder than this. So, you've been very patient, and you've been listening for quite a while. In summary, RxJS shines when you have asynchronous code. Observables can be created from almost any asynchronous concept. We have something called rich composition, which means that suddenly when everything is an observable, we're able to mix and match UI events, callbacks, Ajax, everything is the same, so we can reason about it in a good way. It's very easy to retry. You saw the retry operator, and we had the retry time. Marble testing makes testing quite simple. Cancellation is easy. Unsubscribe is there for you to clean up resources. Remember that if you create your own observables. And as with all nice frameworks, don't use it everywhere. It's not ketchup. Important to remember, because the first time I learned more at depth with RxJS, I started using it everywhere, and then I just, okay, I'm the only one who's going to be able to read this. So don't do that to your colleagues or yourself, because future self will hate you. Further reading, of course. We have the RxJS Ultimate link here at Angular.io resources. This is my free book. It's always going to be free. It's going to cover the basics. You got the official documentation. And I cannot enough recommend rxfil.net if you're starting out. So this is an editor on the web. You're able to code in every single stream, every single operator that you want to try out. And you get a marble diagram, so you see how your values will shift. Thank you so much for listening. Do you have any immediate questions? All right, one up there. Do we have a mic?
What's your opinion about the changes in the syntax? Because with the last update, the dump you mentioned and the pipe, we did engage 2 people for 2 days, only doing this refactor, which doesn't bring any business value. Are these changes going to continue? Because when I was asked what were these people doing, I just said nothing useful.
You have a very good point. Your team is not the only one who suffered from this. I think all us GDs spent 2 days updating our projects. It wasn't creating a business value initially, but I think you're talking about the pipe operator, right? The point with the pipe operator, I'm going to send up a link to you guys so you can see why it's there. It's a very long explanation, but yes, at first glance, why would you change stuff that everybody knows how it works? What does it bring? So the tap brings a very composable approach, and the main reason for the tap to exist in the first place is something called lettable operators. In the past, when you were importing in operators, your bundle became really big. So they needed to do another approach on the library, because everything is about bundle size nowadays, right? We are on the mobile, which means that every single operator counts, so we don't want to leverage the full library. For that reason, they had to reconstruct the entire RxJS, which force you to use this pipe and lettable operators. So every single operator you have inside of the pipe expression is lettable. So to not, I think, collide with the other non-lettable operators, they decided to use the pipe with these lettable operators. But there's more to the story than that. But that's really why. And I agree with you, it's 2 wasted days, but hopefully just 2 days. Thanks for the question. Any more questions? Yes?
From experience, or is it just, is there some, I don't know, checklist or something like sanity check, whether it's appropriate in certain cases to use, or it's just kind of an app?
You mean general, you mean best practices of what to do and what not to do when you code RxJS? Or?
I don't know when to use it, when should I even consider using it? So you say async code, okay, but there are cases when it's okay, just promises and...
I would say it's pretty much what Dan Abramov said about Redux. It's like, if you don't know why you need it, you probably shouldn't use it. But I was trying to highlight when you have cases when you need cancellation, when you got network that goes up and down. If you find that you have those kind of scenarios and you find that you have started to write asynchronous code and it hurts, and you need some kind of way to reason about it in a chained way, then I would say this is when you use RxJS and not promises. But you are right in the sense that a lot of asynchronous cases are happy enough to just do promises. So until you come to that point where, let's say, for example, you got a socket connection. You got data. You got full duplex. The data might actually arrive at any time. This is a very nice example of when to wrap something into observables in RxJS. So because they can actually play nice with your UI events in your application. So autocomplete is a nice one. Imagine that you have the scroll events that you want to keep track of, for example, and you have a user that scrolls and you want some kind of paged way of showing your data. So the more the user scrolls, the more data should be shown. That's another case. But definitely it isn't ketchup. There are 3 or 4 very, very good cases. But I would say when you need cancellation is a good one. When you have more than one value, as I said with sockets, is also a good case. So, but I would say generally you feel when your asynchronous code is horrible. I hope that was a good enough answer. Thank you. Yes?
What would you recommend for marble testing?
You mean test framework or?
No, where we can read more about marble testing, you think it's good?
I cover it in my book, so if you manage to catch that link. There are also some official things written by André Stoltz, I believe. So if you look for André Stoltz on marble testing, he has a nice documentation. He also has a repo that you can go into and check how they set it up. But definitely we need to be better to hand this over to you guys so you see how to do it. Because I think that's the main problem, why no one actually said, yes, I do marble testing. Please.
Can you give us some examples that you often see that we shouldn't use RxJS? Like you said before, we shouldn't use it everywhere, and there are some bad examples that we shouldn't use it. Do you have anything in mind that you often see in the
To be honest, you code Angular, right? Yeah, so in a lot of cases, it's very tempting to use RxJS and use the async pipe and everything is fine. But in a lot of cases, you notice that you can actually just go with promises. If you just have a very simple response request, then there's no point in using it. It's a bad thing for me to say maybe, but that's the reality that you live in. So once you realize that you have a lot of data sources that you need to combine and show it, then it's a better case. Of course, the ones who wrote the Angular framework is going to say, no, 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 Chris, don't say this to them. But that's the reality. RxJS is like promises on steroids, right? If you don't find the cases for steroids, why should I go there? So yeah, I mean, I would say, I would go as far as to say that in most cases you can just do 2 promise on a stream and you're happy about it. But if you have other cases where it's kind of more complex, data arrives all the time, you need to cancel it, or you just want to use all those nice operators. Because in reality, that's what RxJS offers you, right? It offers you a lot of pre-booted functionality with 60+ operators. So if those solve your case for you, then of course RxJS is a good match. So if you find yourself writing a lot of code that RxJS covers already, then it's a good plan to move into it. But if you find that you're just fetching data and that's it, you might as well go with the promise. Yes, any more questions? I'll be here for most of the day and the day tomorrow as well if you want to ask me questions. Yes, please. You mean not the unsubscribe or? Yeah, so this was a very interesting question I got at the last conference as well, because I think you're talking about the case where you fire off an AJAX and in mid-air you want to stop it, right? Because it's a post or put or something. There is definitely in an AJAX operator where you can do abort in mid-air pretty much. So if you know that thing is going to take 3 seconds and it's only been 1.5 seconds, you can just call abort on the AJAX operator. That AJAX operator, though, is covered by the RxDOM. Or you can wrap a vanilla XML HTTP request, because that one has an abort functionality as well. I hope that covers your question. Yes, any more questions? Yeah.
I just was wondering whether you have some lazy evaluation during the chain calls. Because the last one, the terminated one, actually could be something that some calculation that could be excluded in the chain during the code because they might not be needed.
You mean the autocomplete case, or?
If you know, actually, it's something like the Java streams because it reminds me of them.
I would say I just want to correct the autocomplete example, so because most of you is probably going to do the bounce on it, because that's generally a more preferred approach in the UI. That's not exactly what you're asking for, but let me think about this one for a while.
Yeah, because let me put it another way.
Yeah.
You could have multiple filters,
Mm-hmm.
and the last operation in the chain could be something that you don't need to do all the filters during the calls, during the chain.
Mm-hmm.
So is there some kind of lazy evaluation, if you know what I mean? Because in Java streams, there is some steps could be skipped because of the last operation, don't need them actually.
So we have the flat map latest. I'm kind of thinking whether that's a good match for what you're saying.
If you have some collection of 10 numbers, you have to filter them multiple times, and the last operation is find the first. So actually you don't have to go over all the filters because you just need the first number. When it comes to arrays, of course.
Interesting question. I don't think I've had that case, but definitely look me up afterwards and we can talk it through, yeah?
Okay.
Thanks for the question. Any more questions? All right, I'm going to leave you to your ways, but thanks again.